const int pointer, const pointer, const pointer, const pointer, pointer, const pointer, some variable. This is a legit variable declaration, but how do you make sense of it? In this video, I'll help you make sense of this disaster and also why it will be helpful to you. So make sure to hit the like button, subscribe, and let's begin. Let's start simple. We can read this in two ways, from the left and from the right. So int variable or variable that is int, or simply you can call it int. Now let's add a const to the equation. So if we read from the left, it is const int. So that makes sense. Or we can read it from the right, int const or integer that is const. Again, both of them make sense. Now what if it is a reference? Const int reference. That makes sense. Or we can read it from the right, reference to an integer that is const. That also makes sense. But what about pointers? Const int pointer. Wait, what does that mean? I can reassign this variable to some other variable's address. So what does the const mean here? Uh, isn't this confusing? Now let's read it from the right. Pointer to an integer that is const. And that is the right interpretation. It is a pointer to some integer that is const. That means while you can change what it points to, you can't change the value at the location it is pointing. So doing this will give you an error. So that means that the pointer itself is not const, but the value it is pointing to is constant. Now let's see this. Int pointer const variable. How do you even read this from the left? Int pointer const doesn't make that much sense. But if you read from right, it is a constant pointer to an integer. And like the name suggests, the pointer is the constant here. That means you cannot reassign the address that it points to, but you can change the value that is at that address. Being fair to the left reading, you can say that it is an integer pointer that is const, but I don't like it because it feels like we are saying that the pointer is of type integer, whereas it is pointing to an integer. Pointers are always integers that store memory address. See this, string pointer to a const. It sounds like the pointer is of type string, but that does not make sense. It is pointing to a memory address that is string. Now, obviously, the value at that memory address is just bytes, so you can cast it to anything, but this is for type system. Okay, let's see this now. Constant pointer var, int const pointer var, int pointer const var. The above two are the same. If you read from right to left, pointer to an integer that is const, pointer to a constant integer, both mean the same. However, the third one, a constant pointer to an integer, that means different, like I explained. Now let's see this one, const int pointer const var. So if you read it from the right, it's a constant pointer to a constant integer. That means you cannot either reassign the pointer or reassign the value that it is pointing to. Okay, now before understanding the first question, let's take another example, int pointer pointer var. If you read it from the right, again, it is a pointer to an integer. So that basically means that it points to a memory address that also points to a memory address that stores an integer. So a double pointer. All right, now let's read the initial declaration. A pointer to a constant pointer that is also a pointer that is a pointer to a constant pointer to a that is a pointer to a constant pointer that is pointer to a constant pointer that is pointer to a constant integer. Now obviously you're never going to need to do this, and if you do this your team will hate you forever. But what I really wanted to teach you with this scenario was the difference between these three declarations, because this is actually quite common. So this is something you should know. And now there's another way to learn this, and that is if the const is on the left side of the pointer symbol, then the value is constant. If it is to the right, then the pointer is constant. But reading it from right to left makes a lot more sense, and you can extend it to literally anything. Now, do not call me out if this breaks somewhere. I think this is just a convention and not a C++ standard. So yeah, That's it. Hope you enjoyed. If you did, leave a like, subscribe. I'll see you next time.